Now, when you get into the second section of this trig review, what it's really just dealing with is the unit circle. Or again, you can think of it as the trig graphs. I mean, you can think of it as the trig graphs or the unit circle. So most of these values just come from values that are on the trig wheel, right? So like the sine of pi over 3, remember what we had just said? Sine is the y value. So what you'd be doing is you'd be thinking about the trig wheel, and at pi over 3, the y value is the square root of 3 over 2, right? So that's where that comes from. So I mean, most of these, it's just a matter of looking at the trig wheel and knowing whether you're dealing with the x, the y, or the y over x, or the x over y, depending on whether you're given sine, cosine, tangent, or cotangent, right? So what some people do is they memorize this whole thing about ASTC. So then they know, hey, if I'm in the second quadrant, that means that sine, right, since S stands for sine, if I'm in the second quadrant, then the sine function is going to be positive. If I'm in the third quadrant, the tangent function is going to be positive. If I'm in the fourth quadrant, the cosine function is going to be positive. But then in the first quadrant, A just stands for all. They're all positive in the first quadrant, right? So you can see here, tangent of 2 pi over 3. 2 pi over 3 is a second quadrant angle. So sine is positive there, which is why tangent is going to be negative. Okay? And then again, the only other thing really to note here is things like cosecant. When you see cosecant and secant, and even cotangent, I guess, right? You think of these as reciprocals, right? So the cosecant of pi over 6 is really 1 divided by the sine of pi over 6, right? And the sine of pi over 6, right? Well, what is the y value at pi over 6? Again, you can go to the trig wheel if you want. It's a half, so you really end up with 1 divided by a half. But 1 divided by a half, right? Remember, keep, change, flip is really 2. Right? So that's where the 2 came from there. Okay? So, I mean, there's different ways to think about this. You can do the ASTC, and then you have to remember that, okay, like pi over 3, in the second quadrant, the angle that has a reference angle of pi over 3 is 2 pi over 3. And then in the third quadrant, it becomes 4 pi over 3. And then in the fourth quadrant, it just becomes 5 pi over 3. So like if it's asking you for, where's a nice one? Is there a nice one that we can look at here? Well, I guess secant of 4 pi over 3. 4 pi over 3 is the third quadrant, right? So it's going to be, only tangent is positive there, right? So secant is the reciprocal of cosine. So it's going to be a negative. So it's going to be the negative value of the cosine of pi over 3, right? So, because what you really can do is you can just memorize those 4 values, right? Okay, well, what's the sine of pi over 6? What's the sine of pi over 4? What's the sine of pi over 3? And then just adapt those to the different quadrants. So, I mean, hopefully that's a little bit clear. I mean, this should be a trig review, so hopefully what I just said is somewhat clear there, because I don't want to go over every single one of these problems, okay? But what you do is you determine what quadrant it's in, and that'll help you determine the sine, and then you can just look at the sine or the cosine, whatever you're dealing with, of the first quadrant angle, and then just either keep it positive or make it negative to adapt. Okay, so that's the basic evaluating of the trig functions. Now the other ones on here, 15, 16, 15 through 20, I guess, 15 through 21, 15 through 21 are the inverse trig functions, right? So those became a little bit tricky when you got into some of the ones when they were negative, right? So this is saying 15, the inverse sine of a half. So what that's really asking you is which angle has a sine of 1/2, right? Which angle has a sine of 1/2? And then if you go to the trig wheel, you realize, hey, well, sine is y, right? So pi over 6 has a sine of 1/2, but also 5 pi over 6 has a sine of 1/2. So both those angles actually correspond to 1/2, right? Now the problem is, since this is a function, inverse sine, right? Inverse sine is a function, you can only spit back one value. and the value you spit back is pi over 6. And again, that gets down to the whole idea of you have to limit the domain, right? You have to restrict the domain. So this was really asking you which angle has a sine of 1/2. The angle has to be between negative pi over 2 and positive pi over 2, right? Because that was what the restricted sine function was. You restricted it between negative pi over 2 and positive pi over 2. Okay, and then with cosine, right? So inverse cosine of negative radical 3 over 2. Well, remember, cosine is the x value. So where is the x value, negative radical 3 over 2? Well, it's at 5 pi over 6, but it's also at 7 pi over 6. So again, which one do you choose? You choose 5 pi over 6 because this is really asking you which angle has a cosine of negative radical 3 over 2, but the angle has to be between 0 and pi, right? So if I chose 7 pi over 6, 7 pi over 6 is in between 0 and pi. And again, it's the whole idea of restricting the function, right? You have to restrict the function so that it had an inverse, right? And then tangent, you do the same thing. Tangent's a little bit easier, though, because you just restrict it between negative pi over 2 and positive pi over 2, which I think for most people is pretty easy because it's just the period that's in the middle, right? It's bounded by those vertical asymptotes between negative pi over 2 and positive pi over 2, right? So you can see those answers there, and then if there's any questions, you can talk to me in class, right? So these problems here, 22 through 28, these are actually good because it's a matter of looking at graphs and understanding what it's asking you, right? So like what this one is asking you is, what happens to the graph of the tangent of x as x gets close to pi over 2 from the left, right? So as what you're doing here is you're looking to the left, right? To the left, that's that negative sign there of pi over 2, right? What does the graph of the tangent do? So if we scroll back up here to the tangent graph, right? If we zoom in on this, we can see here, there's pi over 2. So what happens just to the left of pi over 2? The graph starts going up, right? So as x approaches pi over 2 from the left, what really happens here is the tangent of x goes to infinity, right? It goes up, okay? So the answer there is infinity. That was where the blank was, right? I don't show the blank under the infinity, but that's the solution. So the solution here is infinity. The solution to the next one is negative infinity. Why? Because this one here, you're asking yourself, well, what does the graph of the tangent do as you get close to pi over 2 from the right, right? So looking to the right of pi over 2, what happens? So if I go back to the graph, you can see that when I'm going to the right of, oops, sorry, I passed it, there it is, right? When I'm going to the right of pi over 2, right? I'm looking to the right of pi over 2, where's the graph? It's down there, right? So to the right of pi over 2, it's going down to negative infinity, right? So that's why I have a negative infinity there, okay? And again, all these are basically the same, right? They're going to be all similar. So what does cotangent, what does the graph of the cotangent do as you look to the left of 0? What does the graph of cosecant do as you look to the right of pi? What does the graph of the secant do as you look to the left of pi over 2? But just a little FYI for my tests, I don't ask you about cotangent, cosecant, and secant because I don't really expect people to, memorize those graphs. I might ask you the 22 and 23 about the tangent, but I won't ask you about those other graphs, cotangent, cosecant, and secant. And then again, now this is what we got into, we talked about earlier with the inverse functions, right? That's the inverse tangent function. You can see what happens with inverse functions. The domain and range switch, right? So the tangent function, if you limit it, goes between negative pi over 2 and pi over 2, and the range is negative infinity to infinity. So here, the domain becomes negative infinity to infinity, and the range becomes negative pi over 2 to positive pi over 2. Okay? Now that other one, this is the tricky one again, inverse sine, because when you limit the sine function, right, you limit it to negative pi over 2 to positive pi over 2. So that becomes the range of the inverse sine function, and the domain just is what the range of the original sine function was, right? So the range of the original sine function is negative 1 to 1. So the domain of the inverse is negative 1 to 1. And again, you can see here, if you go back up to the sine graph, if you zoom in on the sine graph, what you're looking at is, to limit the domain, you're looking at this little piece. I didn't draw it well, but you're looking at that little piece between negative pi over 2 and positive pi over 2. And that's what you're using to form the inverse function, right? And then when you do cosine, where are you limiting it? You're limiting it to 0 to pi. And then you're creating the inverse function from that. Okay, so that's where that stuff comes from. So if there's any questions on this stuff, please see me. Try to come in early before class and we can talk about this, because, yeah, I mean, I didn't explain stuff super in depth here. I just kind of give you like a review. So hopefully this stuff is somewhat familiar to you.